Greetings, hello, welcome. Let's look at more application. More applications of the function rule, which is well known as the chain rule. Okay, some questions here. One question actually requires us to solve or differentiate three equations. All right, our question is find the derivatives of the following functions. They look very easy now. Well, go ahead and do it. Let's go ahead and do it. So how do we go about doing this? Let's start with the first one. Can we use power rule to differentiate this? This can be a question to us. No, we can't. The only way to go about differentiating this, it's by using chain rule. There is no way of running away from that. We have to use chain rule. Why? Because we have a function within a function right here. Cos is a function on its own. Cos x, for example, is a function. But right now what we have is cos and a function inside cos, which is 3x squared plus 2. Okay. So let's go ahead and answer this. Solution. Solutions. Okay. Question 1. Y is equal to 3 cos 3x squared plus 2. Okay. So the first step, what do? We define what u is. We're using chain rule. We know that chain rule looks like this. Dy dx is equal to dy over du multiplied by du over dx. Yes. All right, cool. So we need u. So let's define our u. Say u, let u to be the function inside the overall function, which is 3x squared plus 2. That's our u. Therefore, our function becomes y. We can rewrite that function as 3 cos and bring in u where 3x squared is, because now we know that is the same thing as 3x squared plus 2. So this becomes cos u. Okay. Second step, differentiate. Right? Still remember? So let's differentiate that. So let's differentiate 3x squared plus 2. That becomes du dx, because the variable there is x. Therefore, that becomes, for the first term, we can apply what? Chain rule. So that becomes 2 multiplied by 3x squared to the power 2 minus 1, 1. Yes. Plus 0. And this finally becomes 6x. Right? So that's the derivative for the first expression. And let's find the derivative of this one. This becomes dy. What's the term? What's the variable now? It's u. Dy du is equal to 3. I'm just taking that. I'm just taking a constant out because, the derivative of a constant is 0, but in this case the constant is not alone, so we can separate it and just work with this guy here inside there, and then after that just multiply the constant back in. Okay, so in this case, what is the derivative of cos u? If we differentiate cos u, we get minus sine u multiplied by 1, because we need to get the derivative of u, which is just 1 also. So this becomes minus 3 sine u. Okay, we applied product rule there, but for now we know that the derivative of cos is minus sine. Okay, just know that. Cool. So we have dy du, we have du dx. Now what is the answer? Dy dx is equal to the product of this. Just multiply that with that one and we get our answer. What is du dx? That is du dx. Okay, let me just write it down. Dy dx multiplied by, what am I writing? This is dy du multiplied by du dx, which becomes, what is dy du? This is dy du minus 3 sine u multiplied by, what is du dx? Du dx, that is 6x, and eventually this becomes minus 3 multiplied by by 6, so that becomes minus 18 sine u. Yes, 3 times 6, that gives us 18. You have 6 plus 6, that is equal to what? 12, and then add a 6 there, that gives you 18. Alright, cool. So minus 16 sine u, and what happens? We had an x right there, so times x, then we can write this as minus 18x sine u, which eventually becomes, we know what u is, so let's bring back the value of u. 18x sine, what is u? U is 3x squared plus 2. So 3x squared plus 2, that is our u. Alright. And that is the final answer of dy dx. Cool. Yeah, let's do the second one. Y is equal to 2 sine. Okay, second one. Y is equal to 2 sine 2 theta. Yes, 2 theta plus 2. Well, not 2, but 3 theta plus 2. Okay. Three theta plus 2. Alright. What's the first thing to do? First thing, step 1, define what u is. This can only be done using chain rule. You do see that, right? Yeah, because we have a function within a function. So let u be equals to 3 theta plus 2. Okay, cool. So that function now becomes y is equal to 2 sine u. Okay. Now, what do? We differentiate them. differentiate the functions du, but here's a catch. The variable is now no longer x, but is theta. So we just change, instead of du dx, we change that to du d theta. Okay? And if we differentiate that, we just treat that as an x, but it's just a different variable, which is theta. So that becomes, we apply power rule, that becomes 3 1 multiplied by 3 multiplied by theta to the power 1 minus 1. So this is 3 to the power multiplied by theta to the power 0, which becomes 3 multiplied by 1. Anything to the power 0 is the same thing as 1. So that becomes 3. Okay, that's our du d theta. And what about this one? This one becomes dy du, which becomes 2. Derivative of sine is 1. Cos. So 2 multiplied by cos u. Okay. So tying everything together, applying chain rule. In this case, it will be dy d theta is equals to dy over du multiplied by du over d theta. Do we have dy over du? Yes, this is dy over du. Bring it down here. Multiplied by, what is do we have du over d theta? Yes, it is 3. So this becomes 2 multiplied by 2 cos u multiplied by 3 becomes 6 cos u. Do we know what u is? Yes, we do. So 6 cos, there is u, cos, yes, u, there you are. Yes, 6 cos 3 theta plus 2. And that is our answer. That is our answer for the second one. Alright, last one. 3 x 6 tan. Okay. 3 x is equals to 6 tan 3y plus 1. Wow. Okay. Looks like this one is swapped around. No need to panic. Still the same thing. Pick your u, pick your variables, and apply chain rule. First of all, reminder, chain rule in this case will be dx over dy. So not as what we're used to, but it's just the other way around. Dx over dy, which will now be, multiply that by 1, it will eventually become dx over du multiplied by du over dy. So we need to get dx over du, we need to find du over dy. So let's go ahead and say, what define our u, function of a function, remember. So let u be equal to 3y plus 1. Alright, and that equation now becomes x 6 tan u. Yes, u. Now let's differentiate that guy. That guy becomes, remember, we have u and we have y. So differentiate with respect to the variables present. Cool. So that becomes du over dy, which is equal to power rule there. That's just 3. Done. Alright. Let's go ahead and differentiate this one. This becomes dx over du. This becomes 6. And the derivative of tan is what? You guessed it? Yes. It's sec squared. If it was a variable of x, it will be x, but in this case we have u. So sec squared u. Yes, sec squared u. Alright, so do we have dx du? Yes, we do. Do we have du dy? Yes. So let's go ahead and tie everything together. that becomes dx. dy then becomes, what is this? dx du, that 6 sec squared u multiplied by du dy, which is 3. That eventually becomes 3 multiplied by 6, that is 18. Sec squared. What is u? Remember, we defined u as that, so this becomes 3y plus 1. And this is our final answer. There you have it. Application chain rule. Like, subscribe, and I'll see you next time.